So hi everyone, my name is Fetla and I'm the main organizer of these events, and I'm really glad to see most of you join us today. So let me do a little introduction for what DevTalks is all about. So MentorMate DevTalks is a community for sharing knowledge, experience, and inspiration for people in the software development industry, so people like you. Our goal is to organize a variety of events on-site and online like today, so letting developers, QAs, VAs, and cloud experts and engineers as of today learn about the latest technologies, best practices, and most efficient tools. Since we started in 2017, we have organized more than 15 events in Bulgaria in 5 different cities, and actually that's our second webinar. So welcome. In today's event, we'll discuss bundling application and infrastructure deployment, and our speaker is a very experienced cloud expert. His name is Daniel Rankov, and he's a cloud and DevOps manager at MentorMate. So let me do a little quick agenda for you so you know what to expect. So Danny will talk for around 40 to 45 minutes, and then we have the last 10 minutes left for questions. But don't worry, you can ask them at the chat at any point of the presentation. Just we're gonna answer it at the end of the presentation. So that was my intro. Now back to Danny.
Hello, everybody. Very nice to see you here, and thanks for that interest in the presentation. So first, let me present to you. I'm currently at the position of the Cloud and DevOps Manager here in MentorMate. I'm also an AWS user group organizer. So that's, you can say that I'm very passionate about the public cloud, AWS, definitely DevOps, and agile culture, of course, and practices. I'm pretty heavily certified in the AWS front, and I've just started my certification path in Azure as well. So thank you again. Today, what we are going to talk about is how to bundle the infrastructure. What are the pros and cons around that? Why should we do it? And is it good? Is it bad? And how to do it. I'm definitely hoping for your questions at the end of the presentation. I would love to make a discussion around that. And I like discussing even better than presenting, I'd have to say. Perfect. Starting, I would quickly start with an example. So probably I'm not the only one who have had that type of situation, that an application, the software worked in the development environment. Then we moved forward, we deployed it to the staging environment. Everything was running perfect. All the unit integration tests were perfect. It was just awesome. And then when we deployed on production, well, it failed. So it's not a perfect situation to be. There's a lot of debugging around it. And today we'll address partially a way to move around that, to deploy without having to debug on production and to ruin your customers' experience. So let's look at a sample, sample infrastructure here that we're going to talk about. It might seem a bit complex in the first glance, but bear with me. If we look at that perspective, we usually have a client. In order to distribute the traffic to each and every client, we use a CDN solution to distribute the traffic around the world. And in AWS context, that's Amazon Cloud Front Service. We will also use this service to do routing-based or path-based routing. So it would take all of the requests to a static static resources, probably HTML, JavaScript, and CSS files, images as well, will be kept on a S3 bucket, and the CloudFront will do the routing there. And then all the dynamic requests on probably, let's say, /API will be forwarded back to a load balancer. And that load balancer will redistribute the traffic to multiple compute instances located in an auto-scaling group, in this particular example, in 2 availability zones. So that means that we have a well-architected environment here, and in case of availability zone failure, our software will still be available. And then as a backend, we use a relational database where we've enabled the multi-availability zone mode. Also, for this example, our compute instances would need S3 bucket to store images. Let's say we have an application and our application has profile images to each of our clients. Well, S3 is definitely a good place to store objects. So having this infrastructure in mind, let's see how we can deploy and how we can just bundle the whole solution so we can have a resilient and consistent behavior across different environments that we deploy to. So bear with me again, it might seem a bit complex in the beginning, but how do we start building this infrastructure? The usual approach is first to build the networking layer. So we have the AWS cloud, we deploy the public networks, the private, the VPC here. We do the routing to internet. And that's usually when one of the cloud engineers or infrastructure or DevOps teams would start building the application. Then what do we add on top of that? Usually that would be a load balancer with the compute instances. They are deployed in an auto-scaling group now. So we have the operating system, or if these are containers, we set up the ECS or the Fargate cluster for us. And again, we deploy the load balancer to distribute the traffic. Then what do we do next? Usually we start a single instance of the database. So we can, when we deploy our application, we can verify that yes, it has a backend, everything works good as expected. And then the rest, what do we need next? In order to make our application working, we deploy all the needed components. So our application needed an S3 bucket to store the images. Let's deploy that as well. Let's deploy even more infrastructure to control and manage the access to the bucket. We need to set up identity and access management, roles and policies, maybe also a internet connection to the S3 bucket. So again, a bit more of an infrastructure work to happen there. Then what do we do next? We deploy the static S3 bucket. We deploy the Amazon CloudFront instance, so we can now route the traffic and start sending our clients to the static resources and the dynamic API calls to the load balancer, to the backend themselves. Moving on is where we have a complete solution. We have enabled the multi-availability zone for our database, so we have now a resilient solution. We have also deployed a web application firewall, which integrates with the CloudFront, so we can protect our clients from the rules that we can put into the web application firewall. And that is the whole solution. Let's say we built that for development, right? So that's very good. We now have a development environment, which is great. If you want to move for the next environment and to deploy the code into a next environment, probably when we say, okay, let's now have a staging or a pre-production environment. What do we have to do? Well, pretty much the same thing. Networks, everything as expected. It's very much the same. And now let's build the production. What do we have? I will not go again through the whole process, but the steps are repeatable. And if they are repeatable, when we build infrastructure, there's always that kind of human error that can be made. We can follow practices or we can follow playbooks, but still we can have inconsistencies between the environments, right? We can forget to open a port or in the firewall, right, which will block the traffic. We can enable a specific firewall rule, and it will block the traffic for our clients in just one of the environments. So that's how we have inconsistency. And a way to approach and to solve that problem is, of course, by using the approach, the so-called approach, infrastructure as code, where we codify our infrastructure. And if everything, the public cloud vendors are really good, they integrate really well, they're made for this approach, because creating a server or creating a network, it's in the end an API call. And if we just structure all these API calls and bundle them all together, well, we'll have a consistent environment. So that's how the whole approach of infrastructure as code really help us out in that system. That's how we build. If we build the infrastructure, if we write it as code, first we can execute it multiple times. And what we'll have is a really consistent deployment. So if we write it once for development, we can then execute it for staging, then execute it again for production, and we have full consistency. All the security groups, all the firewalls, everything, all the identity and access management permissions, everything will be the same. So that's awesome. That saves a ton of debugging effort, I'd have to say. Again, it's repeatable, and the best of all, as well, it is auditable, right? Because if the infrastructure that we are creating is as code, where we commit that to a Git repository, we can do peer reviews, we can do approvals, and then it can move to the next environment. So it's a really great approach. And that's just the segue to the whole bundling with the application code topic. So it's a I would say a prerequisite to have the infrastructure written as code, and then obviously we have the application also as code. So let's look at the deployment process of an application. If we say, okay, we have a GitLab here repository, we can build the code, we can then upload it to container registry, and then use AWS code pipelines to deploy it to different environments. We can deploy to staging, development, and production, and have all that deployed. Now, if we think about, that's great. We can create a continuous delivery and continuous deployment as well in terms of application. But the underlying infrastructure, it has to be pre-existing, right? In order for us to deploy our application, we obviously have to have pre-existing the infrastructure. And then we need to have that type of talks. Okay, how do we do configuration management, right? So what is the load balancer name, and so forth, so forth. So let's think about having also a continuous delivery pipeline, excuse me, for infrastructure code as well. So usually we can use tools like Terraform or CloudFormation or Azure templates to do that for us. But think about it. If we deploy the infrastructure in, again, continuous delivery method, we can either deploy it from scratch, or if something is changed, we can refresh it very easily. So this is really great, and the process is automated as a whole. So why don't we bundle that approach and have that? Okay, let's deploy the infrastructure in an automated fashion, right? And then deploy the application on top of it, and it's all dynamic, right? If we want to have development, well, that's perfect. We can create it. If we want to have a feature branch as well, we can deploy the infrastructure and the code all together. And that's, again, by single click, by having a pipeline for the infrastructure and the application, which makes it really, really powerful approach. Now, think about it. If we deploy and refresh the infrastructure, we no longer have any inconsistencies. We always know that the database is at the stage that we want it to be, that the firewall has these open ports that we like it to have, right? That the web application firewall is also configured in the same way as it is on production. So if we want to if we want to create a feature environment, let's say, we can do that. We can do that very easily. We spin up the infrastructure, deploy the application on top of it, then probably a person from the QA team, or we can execute the automated tests on top of that. And then we can destroy the whole architecture, the whole infrastructure, and pay, of course, with having the public cloud provider in a pay-as-you-go model. We will only pay for the infrastructure that we have used. So this is definitely a very, very powerful approach that one might take. And yes, think about it. We reviewed the case with having three environments: development, staging, and production. And we wanted to achieve consistency around them. We wanted to debug less and have a better uptime. Definitely, how we can achieve that? If none of the infrastructure is manually created, that's awesome. If everything is as code, then we can deploy it as in the very same way as we deploy our application. So that's just great. If we want to have multiple environments, well, we can just deploy as much as we want to have, use them throughout the day or whatever our work time is, and then destroy three of them and let the production stage and development still exist. And that is just a beautiful approach. Of course, it fits in some cases. It's not a silver bullet for everything, but if it fits, you can see that how it brings the whole consistency. So a few tools that are very widely used to build the infrastructure and to use the infrastructure as code approach. There is Terraform. It's a product of HashiCorp. They have a lot of great products, Vault and Consul, Packer, among others. Then, of course, the cloud native tools, AWS CloudFormation, is such, and Azure templates, of course, is such. The beauty around having the infrastructure as code, of course, is that if you build it once, you can reuse it multiple times. And then, of course, you can review, just modify the parts that you need to modify, and then just reuse the whole infrastructure. Here in MetroMate, we huge fans of HashiCorp. I have to say, so we heavily invest in Terraform, as well as of course the cloud native approaches. But something that I have to point out here is, if we compare the tools with, let's say, Ansible or Chef or Puppet. Now, where's the difference? Why should we use these instead of the others? The Terraform, CloudFormation, Azure templates, they're descriptive tools when you say exactly the end state that you'd like to have. So let's say we want to have 2 servers started. If we use Terraform and CloudFormation, we'll say, okay, we would like to have 2 servers started. And then if we rerun the same script or the same code, the end state would be again 2 servers running. Now, if we compare that to Ansible or whatever, we might use, of course, Python with Boto3, of course, is widely used, Chef, Puppet, to start instances for us. think about it. If we execute an Ansible script twice, maybe we'll have first time that we'll have 2 servers, and then when we rerun it, we'll probably have 4 servers if one of the others haven't died yet. So that's the beauty of using definite states tools like these 3. And of course, the recommendation is to move on with them. Terraform has its own registry, with modules that one can reuse. So that's really powerful registry. You can go just pull the modules that you need to have in your account, audit them, of course, review them, and just apply them. Same thing about CloudFormation. AWS supports quick starts, and they have good amount of CloudFormation that AWS themselves have written. So you can just go download, take the parts that you want to reuse, and just apply this. As well as Azure templates, they have quick start guides. And yes, it's easy to copy, paste, and reuse code. So it definitely saves us time as infrastructure engineers to create an environment, to deploy an environment, and of course to keep it consistent across projects or across environments. Definitely. Perfect. Now, something very, very important here. If we think about, again, that all of the code is in a Git repository in probably different branches, so we can include peer reviews, and we can have the real power is that we know what is expected to happen. So if we say we want 2 servers, that's what in the code, that's what we expect to have in the environment. So we can audit our environment before it was even created, right? So that's really, really, really powerful. We can have the security teams involved too, while developing, and even before we deploy, they can go through the web application firewall that we rules that we apply. They can review the type of database. Is it encrypted? Is it not encrypted? How about the S3 buckets? Should we encrypt them as well? Well, it's really easy to catch these things even before they were deployed. So that's really, really awesome. There are automated tools also. It doesn't have to be only a manual effort to do peer reviews and to check for encryption, but there are tools like CFN Rippler for CloudFormation, and to TFSec, or of course, there are a lot of other TF-Lint that will check your code automatically. And even before you apply it, they will tell you, hey, you have you have an opened port to the world. Is that what you want to keep or no? So again, even if that's not critical, we still have the awareness. We see what's happening, and again, it's completely automated. And by having the infrastructure deployed in, of course, pipelines, we can have that. We can have that in an automated fashion, which is really awesome. And we keep, of course, having the same pipeline to deploy the code and the application. We have a full consistency over what we want to deploy. So perfect. Now we might say that it works on every environment because we have that consistency, right? We have that full approach. It's holistic, right? When we want to deploy one thing, it's the same as every other environment. We can audit it much faster. We deliver much faster in this way. There's an amplified feedback loop around that. So if that breaks on staging, it will probably break on production as well. We have the security inbuilt, right? everything is fully auditable, it's traceable, and the best of all, we achieve consistency around the environments. So this is really awesome. Um, okay, so there are a few resources, and I'm running a bit faster, I would have to say, but a few resources around that is, of course, the tools that you should know, or I do heavily recommend, is, of course, Terraform, CloudFormation, Azure templates. Use at least one of them, and not for Terraform. You can use providers for AWS, for Azure as well, and of course, there are a lot of other providers that you can use to achieve that infrastructure as code approach. There are books around it. There's even a Terraform Up and Running version 2 book, which I do recommend. So definitely good read for that. A very good presentation that I'd have to recommend. It's about the pragmatic pipeline security by James Wickett. Definitely one of my favorites. It was held lately. There was a delivery conf. So if you are interested in how to achieve security and how to inbuild it into the pipelines and to automate the whole stack. So having the infrastructure as code audited, having the front end code and the back end code made a static code analysis, security scans, just it goes through a whole pipeline. It's extremely good security that I do very much recommend. Perfect. Definitely, I'm running faster here, so I can open for the topic for discussion, and I can, of course, talk more. But yeah, let me ask you that if you have any questions, let's please go ahead.
Actually, we do have one question from Ivan Georgiev.
Okay, I can give you an example to elaborate on this. Let's say that you have infrastructure as a code and you have a specific list of security settings that you apply on your reverse proxy. And at some point you decide that this is not secure enough and you need to upgrade it. If you just have copy pasted the list on 10 different files on your Git repo, you need to do it on 10 times. Do you have some kind of a packaging mechanism, pulling the logic and templatizing, something like Helm for your infrastructure as a code, or how do you handle that?
Yeah, definitely. That's a very valid question, and you can see that question being asked repeatedly. Definitely, it is a valid one. Different people and different projects handle that differently. So what Terraform has is workspaces that one can make use of. That's having the very same code, but when we use workspaces, each changes the state file towards you work with. So you can have multiple workspaces and reuse the very same code. So you change it once and then apply it to every workspace that you have. Sometimes that is a working solution. Sometimes that is not a working solution. So for templatizing it, of course, what one can do, and what I use, is lately I've started to use global variables. So I'm pulling out, in terms of Terraform, again, is that a topic of interest, or maybe CloudFormation is?
I actually have done this on Azure ARM template, so
okay.
It's more generic question about the strategy.
Got it. Well, I don't think there's a silver bullet around it. It depends how many environments you have, right? Yeah, templatizing agent, it would be okay. But yeah, it's a valid question, valid issue. What I do is I use global variables and I pass them through the very same code. Just I pass different variables, if that makes sense, based on the environment that I deploy to.
Were those variables declared?
Well, they're outside of the code, and then we can use whatever, we can use wrapper around the code. We can have a shell or even make files to execute our code, of course, in the proper order, and pass the specific variables containing the environment specifics.
Okay.
But definitely, I don't think there's a silver bullet here. There's not a one size fits all. It all depends on the how many environments you have. And yes, while working now and in the past projects as well, that has always been a challenge. What do we do with the code? How do we keep consistency? How do we version tracking? And that's a challenge. Even with Terraform, there are a lot of ways. Some people use Git tags to set versions. Other people just copy folders. So again, it's specific to
the solution that we took was basically when we standardize a solution, let's say, for example, a load balancer or database or application server or a Kubernetes cluster, we publish this in a, let's say, package form on a repository. And then we have a secondary repository with configuration, referencing specific version of the binary with default configuration. And this is how we are handling. So when we want to upgrade, let's say, to a newer version of our setup, we update this in, first we publish new binary artifact, and then we update the configuration repository. This is the solution we took. I don't know if it's the best one, but for now it's working.
Perfect. Yeah, definitely. If it works, that's perfect. There is not a, again, silver bullet. I've iterated with so many people around that. It's just we'd have to find a way that works best for them. Well, it's if I extend the question, sometimes it's around, okay, if we keep one folder structure, it's easier to develop, but it's harder to deploy. And then if we keep another structure around the parameters and just the code, the infrastructure code, it's really easy to deploy, but it's hard to develop. So we also set that on a par and say, okay, well, maybe we'll focus on that to make the development easier, right? And then we will automate as much as we can the deployment. But it is a trade-off that one should do probably. Again, depends on it all depends on the environment specifics. That's the long answer.
Okay, thank you.
Perfect, Ivan. Thank you very much.
We have another question from Cvetko Krividarev. Cvetko, do you want to just pin up a discussion, or you want us to read it? You may talk if you want to.
Okay, so the question is, from your experience, from your personal experience, is there, like, I know the pros if we use Terraform workspaces, as you already described them before I ask my question. However, do you see any benefit or big difference if we use Terraform workspaces, or if we isolate or variables or the place where we executing the modules in different folders? So you have obviously a centralized module place, and then you invoke them in test, dev, or staging environments, which is different variables. And what do you think is like pros and cons in rather than if you want to use workspaces, something like that?
Yeah, got it. Well, perfect. Just we should understand the workspaces better and what they do. They just add a prefix in front of our state file. So we still, with Terraform, we usually, just for the general public here, Terraform works towards a central state file. And what the workspaces do is add a prefix to that. Let's say if we use S3 as a backend, that's at least what I usually do. So for S3 as a backend, we will have a prefix added. So Terraform will simulate a separate workspace. Sorry, a separate state file. But that works perfectly as long as we don't do cross-module references. And it's not, sorry, because the word module is a bit loaded here when it comes to Terraform, but cross-state references. So let's say a common approach that I usually take is I separate the VPC or the networking module, again, the networking logic and of course, that's based on the best practices that AWS will tell you on how to separate the transformations, and again, best practices on Terraform. So make that, you can do either layered, of course, or vertical slicing. I usually separate the network layer from the rest of the stack. And then if let's say I want to deploy a database, I need to reference to the networking logic. Hey, what is your VPC ID, subnet ID, and so forth, right? So workspaces, they are good if you work in a more of a vertical slicing, when you have all of the business logic or the application logic in one single place, okay? But they will not really work well when you have that cross states references. Does that answer your question?
Yeah, it was, the question was, yeah, exactly, and you answered it perfectly, and it was more from your experience, and thank you.
Yeah, well, that's it. We've iterated, I have to say, being in a service company that allows us to meet with a lot of different clients with different sizes and, of course, project scopes. So a lot of them have different approaches. And I don't want to say that we've seen it all, but we've seen a lot, definitely. Thank you for that question.
Next one is from Margarita.
Sorry, really sorry. Quick question. Do you use any version control on that infrastructure as a code? And
Always.
how do you keep different versions of it? And eventually, if you use some sort of a workflow, branching and stuff like this, you can share a little bit more.
Well, yeah, that's always asked questions. It's usually different branching. The way that my usual approach is to use branches for only peer reviews, but then to only execute the state from a master or a central branch. Because otherwise, when working towards a shared state, if we have multiple branches and then modify the same state, that's like having multiple engineers working towards the same state. And if I make a change and execute, and I change the, let's say, database and something else around it, and there's another person who changes the, let's say, firewall or the security group of the database, right? He will overwrite my changes. And when I do a Terraform apply, I will override his changes, right? So we end up into that not pleasant situation. So one way to approach this is, of course, to do that for each and every person to work in specific services. So let's do a breakdown. Let's not work towards one single shared Terraform state file, but let's break it down to multiple small state files: VPC, database, load balancer, front end, so forth. And this way we can keep consistency. Otherwise, from of course my experience, we should always execute to the code from a single central branch. And of course, that might be master or whatever, however we want to call that, but it should be a single source of truth. Otherwise, we have a multiple sources of truth, which makes them invalid. And of course, that's my approach to branches when it comes to infrastructure as code, working towards a shared state.
Oh, thank you. Thanks a lot. It answers. Thanks.
Sure.
Okay, the next one is from Ivo Nenchev.
What part of the environment is Schablon, and part of this environment is your own decision? Well, if I understand the question correctly, which I will say, what is my decision? Well, it's always it's like the software development. It's always iterative. It's a collaboration between you and the client, and of course, it depends on what you're trying to achieve. What do you optimize for? Is it the cost that you optimize? Is it the well architected that you optimize? Would you like to make that a resilient solution, or just a proof of concept, quick and dirty? So that's a business decision to be made. But even though that we can deploy different components, if we think about the provided example here, we enable the database in multi-availability zone mode to keep consistency and to keep resiliency, right? And we can enable this only on production. Otherwise, when developing, when starting the whole infrastructure, in order to keep it as cost efficient as possible, well, we might say, okay, when it comes to development and feature branches, do not enable the multi-availability zone node. I don't need it, and it's otherwise it will be a waste of time anyway to bring more infrastructure, more than you actually need to do the integration tests and to test that feature, to test and develop the feature. So when it comes to decision, it's about what do you optimize for? And of course, the infrastructure as code gives us that, okay, by using variables or flags there, we can say, okay, let's enable it or disable some parts of it. That's how we can make it again consistent, right? And optimized in the same way. It's the same question as when we start small instance sizes compared to if we have production, compared to big instance sizes, where we can easily have these passed as variables. Okay.
Okay, so that was all the questions in the chat. Is there any questions you would like to raise to Danny now? You're welcome, Ivo. Thank you. Thank you for joining.
Of course, I just have something to emphasize on. And again, we turned the discussion much more into the infrastructure as code approach. And that's definitely what one should be doing, definitely always. If that can be done, let's do it more. But the even better thing here is, hey, by doing infrastructure as code, we can always deploy the infrastructure. But the usual approach is, hey, let's keep the application deployment separate. Let's have the production and development and staging deployed before that, and then we'll deploy our application iteratively, which is perfect. That's okay. That's how most of the companies run nowadays, because they have a separation of duties and so forth. But it's awesome when you think about it. Hey, let's bundle it all together. That's so powerful. So on each application deployment, we can run the infrastructure again. And I'm not saying to recreate production again and again, but we will refresh it. Now think about it. Somebody might have gone and changed some properties. When we do deployment, the Terraform or the CloudFormation or the Azure templates, they will re-verify that everything is that as it should be. So even though that somebody made probably a mistake, and of course that should result in an incident event, in a security incident review. But think about it. It's really powerful to bundle it. Every time we deploy the application, hey, let's refresh the infrastructure as well. That's how we always know that it's always the same thing. I've had production downtimes before because we haven't opened a port in the firewall, right? Or because of the configuration in the database, we had less threads that we otherwise had on the test environment. So how do we keep consistency in that when it comes to small minor details around that? And I think that I intentionally left outside of the presentation is think about how do we keep consistency in when it comes to the operating system. I didn't want the presentation to be too loaded, but Docker and container images, they're immutable, right? So they keep, they are always consistent. So that's the beauty of it. They're fast to start, fast to deliver, fast to deploy, and they're consistent, immutable. So that's awesome. But when it comes to the operating system, how do we treat that question? So what happens? Do we need to upgrade the software that is, if there's a kernel patch available, should we upgrade on production when we have it upgraded on testing? And the same thing with OpenSSL, or let's say Java version, or whatever software we install on the server. So an approach that is usually taken is that the public clouds are made to be used extremely easy with the golden image approach, to build an image and then to use it multiple times. So that's like to treat a virtual machine very much like Docker container. We build it once, we store it into the image repository, and then we deploy it. And when we build it once, we can deploy this image to staging, development, and production. And it's always the same image of the operating system. Nothing has changed, no updates, nobody patched anything. Tools to achieve that are, of course, Packer. Packer we work on, it also works with VMware, but it works very well on AWS and on Azure. So Packer is, again, HashiCorp tool, it's awesome too. AWS have provided their tool to achieve that, AWS Image Builder, to automate the image building process. But again, think about it. You build once the image and then only use it. Nothing has changed. Nothing it's all consistent. And I've worked with customers in this way, where we even stopped the SSH access. So that's a really immutable infrastructure with no access to the instance, right? So that's the real power. Is if the image was tested on staging, well, it's the same binary of the operating system deployed on production, right?
I have a question about that.
Yep.
I mean, if you, let's say you create virtual machines and you treat them as containers, so immutable.
Yep.
In case of Kubernetes, sometimes the application is misbehaving and the orchestrator just terminates the pod and raises it back again. And typically it's all good. In case of virtual machines, when you have infrastructure as a code, do you have an operator doing that? And if he needs to destroy a VM and redeploy from the golden image, does he do it through like bringing a branch, doing pull request to you to approve it? Does it happen automatically? And how do you ensure that your infrastructure does not differ from your Git, which should be your source of truth?
Definitely, good question. Well, of course, we can automate the whole process. We can do continuous delivery on that. We can put manual guardrails. We can do, hey, always use the latest image. So whenever we build new one, we can trigger a rolling deployment, or let's say a blue-green one. But yes, definitely I see the auto-scaling here is in the chat. Definitely we can use even services, native services like co-deploy to do the rotation of and when we bundle that with the application, it's even better. So we have the underlying networks and firewalls and web application firewalls, everything consistent between the environments. We have the operating system consistency, and then we have, of course, the built only, built once application. And that's what is there a really automated way that works on every cloud? No, Kubernetes does a better job on that. But still, there are use cases that containers are not cannot be used. Of course. So again, there is I would say that there is not a one size fits all or a silver bullet, but there are multiple options. We should be aware of the options, and if we work in a auditable or really secure environment, we should be able to provide this first consistency, auditability, and of course shift left on the security. So if we can audit before we deploy, well, that's even better. And with tools like Packer, with Image Builder, we can achieve that. We can first review what is going to be installed, then deploy it, and run this image. Perfect. Well, thank you very much, everybody. I see that even though that we've made a good discussion here, and I hope that you had a good time, and you're always welcome, of course.
Thank you, Danny, for sharing your knowledge, and I hope this was inspiring and pleasant for the others to listen. I just want to wrap this up that I'll say we'll be sending out feedback forms after this event. So if you have any recommendations, they're very welcomed. You can also email me. You have my email address from the Zoom invite I sent you. So some of you have mentioned that they have interest in Azure. Actually, our next event is kind of .NET, kind of Azure. It's package management with Azure Artifacts, and it's on 28th of May, again, free of charge. So if this sounds interesting to you, it's gonna be in our social media and on the website, so please join. Okay, thanks again, everyone, and I hope to see you soon.